Okay, so let's test out this new integration by parts formula on an integral that requires integration by parts. So if we go back to that function x times sine of x dx, if we've already kind of ruled out the ability to use an antiderivative formula or use substitution, so let's go ahead and try integration by parts. Now, the first thing you're going to have to do after deciding to try integration by parts is decide what is my u going to be and what is my dv going to be. So it's choosing these two pieces right here. What am I going to let my u be, and what am I going to let my dv be? And then once we have those, we should be able to get the rest of the material necessary to actually calculate this integral right here. So we'll talk about how to appropriately choose our u and our dv later, but for right now, let's go with these choices. So I'm going to let x be u, and we are going to let sine of x dx, we're going to let that be our dv. So here's the decisions we've made. X is going to be u, and this is going to be our dv. Okay, so off to the side here, let's make a few notes. So u is equal to x, and dv is equal to sine of x dx. Now, what we're going to need in order to use this formula is we've already got u, we're going to need to find v. In two cases, we're also going to need to find du. And we're going to do that by doing some manipulations with these two statements right here. So if we've got u equals x, to get du, we are just going to kind of think about the substitution method. We differentiated from one to the other. So going from u to du, this is a matter of differentiating to get to du. In this case, the derivative of x is going to be 1 times dx, or just dx. So now on this other side, we've got our dv, but we need to get to v. Well, how are we going to do that? Well, we're going to have to integrate in order to do this. So to get from sine of x dx to whatever our v is, we're going to have to integrate in this step. And the integral of sine of x is just negative cosine of x. There's also a plus c in there, and again, we just tend to kind of wait till the very end to include that, but it's still very important. All right, so that's the first part of integration by parts, choosing your u and your dv, and then generating du and v through differentiation and integration respectively. Now all we have to do is put all of these pieces together. So if we go back to the original integral, we've got the integral of x times the sine of x dx, and we know that this is going to be equal to u, which is x, times v, which is negative cosine of x, minus the integral of v, which is negative cosine of x, times du, which is just dx. So take a minute and make sure that you're okay with what we've set up here. We've essentially just applied the formula for integration by parts using these four parts that we've collected: u, du, dv, and v. Now it's just kind of a matter of cleaning up and dealing with that next integral sign. So I'm going to rewrite this as negative x cosine of x, and then I'll pull that negative out front to make that plus the integral of cosine of x dx. So integration by parts is always going to require us to then deal with this extra integral, the integral of v du. Hopefully it's something that we can handle. In this case, we know how to integrate cosine, that's just sine, and now we're done. So we've got negative x cosine of x plus the integral of cosine, which is sine of x, and then we'll put on that plus c. All right, So that's a nice basic example of how integration by parts works. Now, a couple things to keep in mind at this point. A tip I would consider is that it's usually easier for us to choose the dv first. So in terms of what's my u, what's my dv, I'd encourage you to consider choosing the dv first. And we're going to talk a little bit more extensively about that in a minute. Don't forget, dx is always going to go with that. And in general, we try to pick as much of the integrin that we're given that we can actually integrate, because usually integrating is the more difficult task for us in these problems. Differentiating tends to be easier. And just kind of keep in mind, these can be very frustrating. Successfully working through integration by parts is going to take practice. It's going to take trial and error. You're going to develop your intuition as you get through there, and it doesn't always work. So that's sometimes the frustrating aspect of these techniques, is that it's not always going to work, and that's where the intuition is going to come in as we work through these. And as far as that building intuition, let's take a look at what would have happened if we hadn't chosen the correct pairing of u and dv for this problem. So if we didn't let x be u and sine of x dx be dv, what if we had done it the other way? What would have happened? So if we had chosen u to be sine of x, then our du, we'd differentiate and we'd get cosine of x. And if our dv is x dx, to get v, we would integrate, which would give us 1/2 x squared. Oh, I forgot the dx with that cosine. All right, so these are our parts. So let's put this together for our integral. So the integral would be u times v. So that would be 1/2 x squared sine of x. So that's our u times our v, minus the integral of v and then du, which would be cosine of x dx. Now what's happened here is this integral would require us to do integration by parts again. And it's, sometimes we do have to do integration by parts twice, but in this case, it's so much worse than our first choice that we'd probably want to question whether or not we had set this up correctly. We'd get to this integral and we're like, oh, that looks a little bit unpleasant. I've got to do integration by parts twice. Also, this integral that I'm taking here is more complicated than the original integral we even started with, x times sine of x dx. So that might lend us to think I may not have chosen correctly here. Let's go back and try it again. Now, with that in mind, there's also another tip that I wanted to share. So since this is, I'll just kind of make a note here that this is worse than the original. The original integral, which should be a sign for us to maybe think of something else. So let's consider this is a suggested hierarchy that you can use for choosing your dv. We'd already talked about that choosing dv first might be a good idea. So let's work through this. So our first choice for dv, it should always be the dx. So dx should always go with dv. And sometimes that's the only thing that goes with your dv, as we'll see in some examples. The second thing that we should choose is exponential functions. These are things like e to the x, 6x squared plus 1, functions where the variable is in the exponent slot. Our next choice for dv might be trigonometric functions. Specifically trigonometric functions that we know how to integrate. So things like sine of x, things like secant squared of 4x, these are all trig functions that we can actually integrate. After we've gotten through those possibilities, then we're going to lump in algebraic functions. So algebraic functions are just functions of x that involve just powers or radicals, adding, subtracting, basic algebraic maneuvers. So things like a power function, a square root function, a rational expression, these are algebraic functions. All right, inverse trig functions. So inverse trig functions. We're really kind of getting to the bottom of the barrel here. So something like the inverse sine of x or the arctan of 5x. Again, the big problem here is that we don't know how to integrate these variables. We don't have formulas for them, at least. So they become kind of our last resort for a DV. And the very bottom of the list is logarithmic functions. So things like the ln of 2x, log base 5 of x. So at the top of the list, what we have is we have expressions that make better dv's, and at the bottom of the list, we have functions that make better u's for our problem. So we kind of just work through this list as we're kind of thinking about it. And if we look at this, if we look at the first letter of each of these that I've kind of put out here, we could remember this using the acronym detail. That might help you kind of remember this. Like, okay, I need to pick my DV. What do I choose? You kind of run through this. So the acronym detail may help you with that. All right, so we've talked about integration by parts. We've gone over the formula. We've gotten a few tips. Now we're going to kind of just work through some problems to see how it pans out for us.